Perfect. Our next speaker is going to be Ian Selby, and he's going to be talking about automated quality control of chest X-rays.
I'll introduce myself anyway. My name's Ian, and I'm a PhD student and a radiology doctor at Addenbrooke Hospital. And I started my PhD working with a large group of clinicians and mathematicians, data scientists, and so on, led by Corolla in Cambridge. And that will become important in a second. But the group did a systematic review about a year ago of all of the COVID-19 diagnostic and prognostic models that used imaging, so mainly chest X-rays and CT scans. And they found that not one of the models was appropriate for clinical use at that time due to methodological flaws and biases within the data. Subsequently, there have been a few papers that have looked into why these models have failed to generalize to external data sets. And one of the big causes is shortcut learning, where the model uses the easiest way to get the answer out of the problem, because it doesn't given the context. So in our own experience of training a chest X-ray model, I put up 8 images of saliency maps there, and you can see there's quite a high reliance on image annotations, tube, pacemakers, and clips. So this was a problem, and we wondered how we were going to get around it. So we decided that we had a huge number of chest X-rays, and it was very hard to get someone to go through them all and label them to allow us to stratify and so on to try and remove these biases. So we thought we'd develop an automated tool that would try to label these biases so that we could stratify or use another technique to penalize the model for using them, or correct the image where possible. So can we remove the annotations and not create something that the model still uses to cheat? So we used statistical techniques where we could quite simple things, and then quite basic convolutional neural networks to do it. And our aims were to improve model generalization and try and promote ethical AI, because if I was a patient and my chest X-ray said I've got COVID because it had text on the image, I'd be slightly concerned. And also to facilitate faster model development. So if there's another pandemic, can we develop models quicker without someone spending a month going through the images, trying to label them manually? So we did that with a large data set we had. We kept 2 of the data sets for training exclusively and 3 of them for external validation of all our models. And we ended up with a 3-stage process. So it's basically version 1. The idea is that hopefully this will reduce confounding and bias and shortcuts, but it's certainly not going to be the whole solution. So the first step is to standardize the images where possible, apply lookup tables and so on to try and make the images the same as possible. Rate image quality by looking at the range of pixel values in the whole image, center of the image. And also we noticed about half the images had inverted grayscale, half had grayscale you would expect. So you can see a couple of images up there where the body's black and the air is white, which is the reverse of what we'd hope to see. So that is step 1. In step 2, we remove any image annotations, crop any black padding around the image, and also eliminate images based on aspect ratio. So there's some images that only contain, for example, the tops or the bottom of the lungs. And just by using a simple aspect ratio, you can eliminate a good portion of these. And finally, we correct any 90-degree rotation. We look for any lateral chest X-rays, because obviously they're very different to frontal or backwards chest X-rays. And we label the view. So the gold standard is to take a chest X-ray from the back to the front, but that requires patients to be well and able to stand. So lots of patients have them from front to back, particularly during COVID. So if you're sick, you'll have an AP chest X-ray. And during COVID, they did APs because of infection control reasons as well. And we also label pacemakers. So that's all well and good. And we had good performance in all of these models. So, but what does that mean? So that's where we are at the moment. And just to give you an example of the downstream experiment we're working on, for the model that looks at that projection, whether it's taken from the front or the back, we have a chest X-ray on the left with the annotations still on the chest X-ray and an annotation on the right with no annotations. This was strangely a PA, which had some annotations, which is unusual. And we classified it as AP. As a result of those annotations, well, likely to result of those annotations in the corner. When you remove the annotations, the prediction flipped, and the model got the prediction correct. So that just shows how something as simple as removing the annotations can flip the prediction and hopefully eliminate some bias. So that's it. Anyone who's got any questions or anything to catch me in one of the breaks? Thank you very much.
Brilliant.